like OpenAI Gym to create the environment, and stable baselines 3 for training the agent, right? Now, in that, we saw that we were already using OpenAI Gym environment models that were pre-existing, that were already available in the repository. Now, let's say you want to train your own agent, or you want to train your own environmental setup. How do we do that? So if you want to create something out of an application from your own, so how do you make that particular thing compatible with the Gym env? So once we have this knowledge, we our aim today is we'll create a custom environment and we want to make it compatible with Gym. Okay, so once that is done, just training it on stable baseline 3 is a simple process. We just copy paste the code that they had to train an agent. That is very straightforward, and we can have the training going for us, right? Meanwhile, if you have any questions from yesterday or anything before that, please feel free to ask. So this is, I'm just opening the tutorial that I had shown yesterday, where towards the end, if you remember, I had shared this link with you guys so that you go through it. So in case you're joining today for the first time, I'll try to go through what these guys have covered. And if you can see, I have some tutorial folders open that I had worked with earlier for creating my custom environment. So I'll discuss that today as well. So yeah, let's get started. Meanwhile, if you have any questions in between, feel free to stop me and I'm happy to answer your questions, right? So I'll just try to execute all these code blocks one by one. So first, they want you to install this for visualization. So let's get that installed. Yeah, and then you install stable baseline 3, right? So you just do pip install stable baseline 3. And because this is a Linux command, so you add a exclamation mark, right? So you guys are familiar with Linux, using Linux PCs, right?
Yeah.
Okay, great. So yeah, I installed stable baseline 3. It's a simple pip install stable -baseline 3. And this extra basically installs some additional toolkits. If you need it, it's fine. Otherwise, even if it's not useful for you, you can remove this part. But I think for this tutorial, they have used certain libraries. And this is something called SB3 contrib. So this, I said, it's like a beta version of stable baseline 3 that has some additional algorithms. Those are not very stable to be included in the stable baseline's original branch, but so they have created a separate branch called stable baseline 3 contrib. So it has certain additional algorithms that you can implement. So that's this also I installed. Now getting started. Okay. So environment that follows the Gym interface is quite simple to use. It provides the user mainly 3 methods. Okay. So basically you create a class for the environment, and in that class you have the constructor. And apart from that, you have 3 different methods, right? So first method is called reset. So this is called as at the beginning of an episode. So what it does is it returns an observation. Okay. Step function is called to take an action within the environment, and it returns the next observation, whatever is the next immediate reward, whether the episode is over, and any additional information, right? So step is basically once you take an action, the environment processes that action and returns you what the next state, the reward should be, right? And this part, render, is optional. This is something that allows you to visualize the agent in action. Okay, note that the graphical interface does not work on Google Colab, so we cannot use it directly. So we have to rely on method RGBArray to retrieve image of the scene. Okay, so here you won't be able to see a pop-ups video screen. So that's why they are using, instead of using method is human, they are making use of RGBArray. So you can see images. Okay. But again, this is optional. Even if you don't define this method, you should still be fine. Unless, as long as you care about visualization, then we should worry about populating this particular method. Otherwise, it should be fine. And then we discuss under the hood, it contains two useful properties that are very important. One is the observation space, one is the action space. What is the observation space? Observation space is basically telling me that observation space basically is the set of all possible observations that an agent can visualize or see during its entire simulation, right? It is we define the range from the minimum to the maximum that each different observation can take. And this observation space can be of two types. It can be either of a discrete type. So if you have a discrete kind of an observation, like for example, the tic-tac-toe environment. So if you encode these 9 boxes into zeros and ones based on the presence of x's or zeros, or let's say, if not a binary hot encoding, if you make it a trinary hot encoding. So let's say x's are represented by 1, zeros are represented by 2, and an empty square is represented by 3. So then you will have around 3 power 9 different states, right, for a tic-tac-toe environment, and all these states are discrete, right? So then you make use of this discrete data type, okay. And otherwise, if it's a continuous environment, you make use of a box data type. Box is for continuous, right? Same as for the action space. It describes the action space so that so you call the action that can be taken. The best way to learn about gem spaces is to look at the source code, but you need to know at least the main ones, right? So gem spaces box, or possibly unbounded box in Rn, okay. It's a n-dimensional real plane. Specifically, a box represents the Cartesian product of n closed intervals. So each interval has the form of AB, either this or this or this. So example, a 1D vector or an image observation can be described with the box space, right? So this is how you define the box. You define the low, you define the high, you define what the shape of the box is, and then you define the D type, okay? So here, let's say the observation is an input, okay? So their input looks like this. So they have a height, they have a variable called height, they have a variable called width, and they have a variable called number of channels. So if it's an RGB array, it's a 3-channel image, right? If you are dealing with different sensory images, then the number of channels might vary for you. And low and high basically tells me the range that each pixel in that image can take. So since I'm assuming it's an RGB image, so they are having the low from 0 and high till 255, right? And gem.spaces.discrete is you just call discrete 2. So if you call discrete 2, then the possible available observations or the possible available actions would be 0 and 1. Okay, it's from 0 all the way till n-1. Okay. Now, what they have done is they are trying to create a custom environment. Okay, so they have imported the necessary libraries. Okay, and they have called this particular function. Okay, so take a look. What this does for me is, so this is basically a check function that tells me if my env is compatible with gem interface. Okay, this is we do at the end. So once you have created your custom environment, you call this function and check whether the environment that you have made. So it does a bunch of checks in the background, and it tells you that if it runs successfully, then you know that your environment is completely compatible with the gem interface. If it throws any error, you need to go back and change stuff behind. Okay, so here they have defined the gem observation to be something like this. So this observation is basically a union that it consists of a tuple, it consists of a dictionary, of numpy array, and integer data types. Okay. So yeah. So first, to create a custom environment, so you first create a class called custom env, and you pass this superclass to it always. To create a gem environment, you always pass this superclass called gem.env. So it's the parent class that the custom environment will refer to. And because you have done import gem, you are accessing the env method from the gem environment, and you're passing it when you're defining your class. Okay. Yeah, by the way, please stop me if you feel I'm going too fast, or if you need any clarifications at any step. Okay. So yeah, remember, you need to make a super call to the gym.env module when defining your class. Okay, so this step is important for creating a gym, your custom gym environment. And then you call the def init function, you call the self. And then this is important. Why? Because you are making a call to the gym.env. So you need to make a super call to that module, right? So just follow these steps, like try to make sure that you, after the init, you have this super.init. Okay, so this step is important. Otherwise it will throw an error. And then you go ahead, you define your constant variables that you will be using throughout, okay, the environment. So the constant variables, and make sure that these are the member variables, right? So these are member variables of the class that you are defining it under, right? So you define a bunch of constants, you define what are the what is specific to your code. So you define a bunch of initialization statements. And then lastly, you always do this. Okay, you define the observation space and the action space. And please note that the word should be same. Okay, so this is a keyword. If you call it a state space, then it won't work. You have to call it observation underscore space. Okay, self.observation underscore space and self.action underscore space. Okay, so what they're doing is they are calling gym.spaces.box. So the observation is a continuous observation. Low is from minus infinity, high is till infinity, and the shape is 14 comma. So that means it's a 14 element vector. It's a single 1D vector having 14 elements, right? Similarly, the action space here is also continuous for them. So they are saying that the action is a continuous variable from -1 to 1, and the shape is a six element 1D vector. Okay. And then once you have the init class, so what this init does for me is it is the class constructor. Okay, so this is the first step you need to do when you're defining your custom gym env. Secondly, you need to call the reset function. Okay, so we have three methods apart from the constructor, right? We have the reset, we have the step, and we have the render, but the render is optional. So here, if you see, they don't have a render function defined, right? So this reset function is the second thing you need to do. What it is, reset the env to the initial states, right? So this reset function takes no argument. Okay, just like the init. Init can take argument depending on your needs. Reset typically doesn't take any argument. Okay, and what it returns at the end is basically an observation. Okay, eventually what you should be returning is an observation. So whenever I call a reset function, whatever it returns would be my observation. Okay, so here for simplicity, they have decided to go with a observation space.sample. Any random sample would be considered to be my initial state. Okay. Now this is where the main stuff happens in the gym environment. Step function takes an action, processes it, and returns the next state, reward, done, and info. Okay. Next state is obvious. You know what a next state is. You know what a reward is. Reward is basically the instantaneous reward. Okay, it's not the cumulative reward, it's the instantaneous reward. So for taking action 80, what is the reward I'll get at that time? That is RT. Okay, so now if you make your setup to be a sparse reward kind of a setup, so then you can consider RT to be 0 or RT to be none for that matter. But typically, yes, it is assumed that you kind of get a reward, an immediate reward for the action that you have taken at that particular instance, right? And done is basically a check that you make to basically see how well your sorry. So done is basically a check to see if the goal has been reached or not. Okay, simple as that. And info is a dictionary that helps you to return some additional information, right? So here the step function, including self, you pass one argument, which is the action, which is obvious, right? You need to pass an action, and based on the action, you will take a step. Okay. And what the step function returns to me is OBS, reward, done, info. What is OBS? Here they have decided to be observation space dot sample. Okay, reward is 1, done is false, whether the termination was due to timeout or not. So the termination can be due to two types. Okay, one is it can terminate because of a failure case, or it can terminate because of a success case, right? So so people actually call it as termination and truncation. Okay, so termination versus truncation. Okay, so what do you think? What is what in this case? So will I terminate my action when it's yeah? So okay, I'll answer that. So if I take a wrong action, which leads me to a state where there is no recovery, or it's like a which results in the failure of an episode, like for example me crashing my car into a wall. Okay, then it's a failure case, like my agent is dead. Okay, that's a termination. Okay, truncation is, let's say you have an infinite length of an episode, like we discussed yesterday, right? So you don't have an end of an episode, so you fix the end after a very large time, capital T. You say that after a certain time, capital T, I am more or less satisfied with the behavior that the agent will give me. Okay, and because in RL we follow the Markov property, if you design small if you define small episodes of time, capital T, the Markov property essentially tells me that I can stitch these two episodes together to create one long episode, right? Like the end of the first episode at capital T, and if I create another episode that starts from that capital T and goes all the way till capital time 2T, I can essentially switch them up without any loss of generality, right? That's what my Markovian property tells me. And that is again an assumption that we need to, sorry, that is something that we need to follow in an RL model, that the observation space should follow the Markov property. Okay, that is necessary. Okay, so you return the obvious, reward, done, info, and then here you are creating an instance of the class. Okay, so you create a variable called env that is instantiating the class. So you don't have any necessary argument apart from self. If you had, you might need to pass it, but since we don't have, we create an env. And then you check your custom environment. Okay, so this will print warnings and throw errors if needed. So I run this. If it shows no error, okay, your environment must inherit from the gym env class. So it is throwing error to me, right? So we need to go back and change. Okay, one more thing I should tell you, that this tutorial was created in 2022, right? But since then, the gym original code for OpenAI Gym, they made a lot of changes. Okay, so now it's no longer called gym, it's called gymnasium. So I'll do it, import gymnasium as gym. That should solve my problem. If I run this, yeah, you see it will throw a lot of errors now. So I need to make a lot of changes. So what it tells me is that the reset must accept a seed parameter. So in reset, apart from this, you need to add a seed parameter. I need to add an options parameter. Okay, these are the two new additions in the latest version. And yeah, these changes have been very latest. Like these are hardly 4 to 5 months old. Okay, but I'm telling this to you so that you stay updated, because when I downloaded this stable baselines 3 over here, so this by default downloads the most recent version. Okay, So we need to make certain changes. So a reset function, apart from self, needs to pass a seed and an options. Okay, you keep it none. If you want to pass a seed, you can pass it accordingly. So any idea what a seed does here? Like what is a seed used for?
Essentially for anything random that is generated, we use a seed.
Yeah, so if you use a seed, you can generate the same random configuration at a later time. So let's say if I set my seed to be 100, so whatever configuration I have for seed 100, that configuration is fixed. So if I want to test it later on seed 100, so I just need to pass the same seed. It will generate the same random environment for me. Okay.
It's understood.
Yeah. So if you have any seeds that you need to pass, that you can do, but the default is none. So I'm keeping it none. Now let's run. Okay. Reset must return a tuple, OBS and info. So reset no longer returns only the OBS. It should return OBS and an info, right? So you should have OBS as this value. Let's make this. Okay. And it returns an info, which is a dictionary. So if I do this, okay, now return should be fine. Like this is a change that they added. Okay. So instead of returning the state, it is also returning an info. Okay. Whatever extra information you want. Now, if I run this, now reset is fine. Step function must return 5 values. Okay. So OBS reward terminated truncated info, actual 4 values returned. Okay. Now this is a big change. So instead of done, what they have done is they have separated it out. Okay. They have, instead of done, they are calling it terminated and truncated. Okay. So these are two new parameters, terminated and truncated. Okay. I'll make this false. Okay, so now we don't have done info. Instead, we have termination. Sorry, terminated. That's the word. Or rather, it doesn't matter. It should return 4 values eventually, right? The variable name is irrelevant to us. Yeah, this returns initial OBS and info. Okay. This needs to be kept in mind, and I think we should be good to go. Yeah, now you see there are no errors here. If I run this again, I don't get any more errors. That means the custom environment that I created is now totally compatible with the gym interface, right? Now all you need to do is you need to fill up what you actually need to do. You need to change your init function. You need to define your reset functions, step functions, and so on. But this is compatible with gym env, right? So if you want to train this gym environment, once you have created a proper environment, you can directly call stable baseline 3, and stable baseline 3 first checks if the environment is compatible with the gym interface, and if it is so, it starts training immediately for you. Okay. So any doubt so far with the custom gym? So this is like a skeleton class that they have defined, right?
Say suppose you have like defined a environment which is like suppose you have done using graphical user interface, like you have used some pygame or some library. So
Mhm.
how do you convert it? One question is like how do you convert it into a normal environment? Second is like if you want to have it compatible with gym and you want to retain your
Mhm.
graphics and all that. So how do you do that?
So environment graphics is all part of the render environment, right? Sorry, the render method, right?
Yeah.
So what you want to basically take your observation as the image at that particular instance and decide your action. Is it
Can you
what
repeat?
you're saying? So is it like you have a Pygame graphic and you want to take your input as the image at that time instance as input to the RL agent?
Uh, The image is not an input. The image is just like it's like a representation of what is going on, right?
Right.
The image can be a normal, it can be a data structure of a combination of lists and arrays and stuff. That is not an issue.
Yes.
But just for visualization purposes, like after taking every step, you want to see the action, like how it is in the frozen lake environment. So how do you do in those cases?
You just create the render function, and whenever you do env.step, afterwards you call an env.render. That will give you a visualization at
Okay.
that step. So
Okay,
that's
like
what I said. You need to have a render function separately.
okay, so if you
Okay.
are, say suppose you are using matplotlib for the images, then you can just do plt.plot, right? After
Yes.
the
Yes. Yes. So I'll not use render class. So maybe if I use something like render underscore. Okay. Now if I want to, sorry. Okay. So this is not a one of the method classes, right? So I just created a new function called env render underscore. Okay. And if I want to visualize it, I'll say import matplotlib, and I'll say plot the current graph. Okay, at that step. So because it's a member of the class, I can do that. And in addition, I can also define multiple other functions. So if I want to define some function like this, I can do that. Okay, so Gym doesn't restrict you to stay limited to these three methods. You can very well add more functions to it as you seem necessary. Okay, but all it tells me is that these three functions should be there. Apart from that, anything you add is good for it. Does that answer your question?
yeah, thank you.
Okay, just a sec. Yes. Yeah, so now this works, right? Now, Stable Essentially works on an environment that follows the Gym interface. You can find a list of available environment here. It is recommended to check the source code to learn about the observation and action space of each ENV. As Gym document is still a work in progress. Not all algorithms can work with all action spaces. You can find this in this recap table. Okay, so you have a bunch of algorithms, right? So here, they're actually telling us, okay, so what algorithms can work with what kind of a setup? Okay, so not all algorithms support the box and discrete. Like for example, if you want to train with SAC, right? So SAC algorithm doesn't support discrete actions. Okay, so this table tells me, so if you have a discrete action, you are better off using something like PPO, something like HER, something like A2C, something like ARS. Okay, these support discrete actions. Similarly, you have a check for discrete observations and so on. So if you go to the Stable Baselines website, so they have a detailed list. Okay, what is allowed, what is not allowed. Usual cases, observation, it can both be discrete and action. It can both be discrete and a continuous observation. Only support is for the discrete and continuous action. And this support also stems from the way the algorithms are designed. So if you look at the original algorithm as to how soft actor critic is designed, okay, how the algorithm works. So you will understand that the algorithm is meant only for a continuous action space. Okay. Similarly, DQN. DQN is designed to work for a discrete action space. The moment you have continuous action space, DQN is invalid. Okay, you don't know what to do with DQN. Okay, so that's the way the algorithms are mathematically, right? So just take a look at this table before using what all algorithms you have. You need to check specifically for what kind of support each algorithm gives us. Okay, so I'll just import Gym. I'll import NumPy. So from Stable Baseline 3, I'm importing these 5 algorithms: PPO, A2C, SSE, TD3, TQN. And from Stable Baseline 3, there are 2 algorithms which are not present in the original repo. This also, let's say we import. Okay. The next thing you need to import is the policy class that will be used to create the network. This step is optional as you can directly use strings in the constructor. Okay, so you can either do MLP class import PPO.policy. Sorry, if you can do this directly. Even if you don't do this, if you put it inside strings, then also it assumes that you are specifically calling for this, and it accommodates for that. But if you want to use it without strings, then you need to specifically import this particular policy class. Okay. Now you create the environment, instantiate the agent. So for this example, we'll use a pendulum environment. So inverted pendulum swing is based on the classic problem and control theory. It consists of a pendulum attached at one end of a fixed point, another end being free. It starts in a random position. So random in this case is somewhere at the bottom half. And the goal is to apply torque on the free end to swing it into an upright position with its center of gravity right about its fixed point. Okay, so the environment is over here. This I think we saw yesterday. Oh, yeah, in the gym website, we saw this environment, right? So we chose the MLP policy because the observation of pendulum is a feature vector and not an image. Okay, so if you have an image, you don't necessarily use an MLP policy. What kind of policy do you think should work for an image? Why do you think images won't follow the MLP policy? Anyone? Just say anything. Let's discuss. You don't have to give the correct answer. Just I want to know what your thought process is like.
I think yesterday you mentioned like CNN policy as well.
Yes. So the CNN policy is what you should use for images. But why do you think MLP policy would fail for an image?
Like because in an image it's like a 2D
2D.
matrix
Yes.
of pixels.
Yes. So unless you are flattening that 2D NumPy array into a single 1D NumPy array, then you can use an MLP policy. But if you don't want to flatten it, you want to feed in the image as is, then you need to use a CNN policy, or depending on the different types of images that you have, there are different policy classes. But yes, most of our cases, we use the MLP policy for, let's say, in robotics applications. Sometimes we deal directly with the sensor images. So there we use a CNN policy. So what the CNN policy does is, before the actor critic or before the RL model, it adds a CNN beforehand. Okay, so the CNN is basically extracting a feature, and then that feature is being fed into the RL model. Okay, so there is a CNN which is being added to that, but we don't see that because it's all a part of the black box, and everything is trained end to end. But there is a CNN that is also being trained in this case. Okay. So the type of action to use will be automatically deduced from the environment action space. Okay. Here we are using proximal policy optimization algorithm, which is an actor critic method. It uses a value function to improve the policy gradient descent by reducing the variance. Okay. It combines ideas of A to C, TRPO. It's a non-policy algorithm. So it is discussing more about what the PPO algorithm is. If you want to understand more about it, I had suggested this website, right? Spinning Up AI. You can go there. You can understand in detail what each algorithm does. Okay. So here, what they're doing is creating a gym environment. So here, I'm using gym.make. Why? Because I'm making a call for an environment that is pre-existing in the gym repository. Okay. If I want to use my custom environment, I don't need to make a gym.make. I can directly call custom env bracket, and that should make a call to my env. Okay. And here, once you create the gym environment, so env loads the gym environment. Now you create the RL agent. Here we are using tuned hypoparameters. So you create model. So one thing you pass is MLP policy, you need to pass the env. And all these values are additional additional arguments that you can pass to the model. But these usually take on the default values. Unless you want to modify it, I would recommend you use what stable baselines already use this. But yes, if you want to experiment, play around, you can always change different values. Now you need to read about what a gamma is. You need to understand what an USD is, learning rate is. Okay, that I don't want to go into the detail of what each argument does. So I'll just run it as it is. Okay, so now it said that we are making use of a CPU device, wrapping the environment with a monitor wrapper. Okay, and wrapping the environment in dummy with env. So this also is something that I won't cover probably this time what this does. These are slightly more advanced concepts. Okay, now what I'm doing is I'm printing the observation space and the action space. Okay, if I do env dot observation space, okay, so what it tells me is for this pendulum environment, my observation space is from -1, to 118. Okay, these are the lows, these are the highs, and this is the shape. And the action is also a box from -2 to 2. So typically it's the torque that you are applying from -2 to +2. Okay, and to that, if I want to just do a sample, so if I do env dot observation space dot sample, that returns me a random observation. Okay, and this random observation should always lie within these range, right? I run this again, I do this. If I run this again, I get this. And similarly, if I want to do a sample of the action space, it is always a number between -2 and +2. Okay, this is clear, right? So now we need to retrieve the first observation. So what do you think I should write over here if I want to retrieve the first observation? Anyone? So this is something I have to fill. If I want to retrieve the first observation, so far we have covered what a gym env does, right? So what do you think I should be adding over here?
Guess it's like a normal array indexing.
Sorry?
Not. I guess it like the observation space is like returned at the start of every episode, right? So we can
Yes.
check it in the dictionary directly.
No, there's a better way actually. You can directly do env.reset, right?
Yeah.
That is the fastest way. Now if I do print OBS, that retrieves my first observation. Okay, that's why we have the reset function. Okay, so that if you want to retrieve the first observation, instead of looking up into the dictionary, you just directly call the env.reset. Okay, that is the way you retrieve the first observation. Okay. Now I want to predict the action to take given the observation. You want to predict an action. Okay, how do you do that? So the action prediction happens from the model level, right? So it's not at the environment that predicts the action. Okay. So this is how you do it. Okay. So you say action is equal to model dot predict and OBS. Okay. That's it. And yesterday, if you remember, we had this deterministic is equal to true. If you want your action prediction to always be deterministic, but by default, it is a probabilistic prediction that you are making. Okay, so if I do this, I predicted my action, and if I see what my action prediction is, it is bounded between -2 and 2. Now, just to give you a heads up, I haven't really trained the model yet. Okay, so what the model is predicting? What do you think? I haven't trained the model anywhere, right? I have just instantiated the model over here, and I'm doing model.predict. So what is it returning to me actually? Exactly. Anyone? How many people are there today? Let's see. Okay, 24. Anyone? What do you think this is doing? Let's discuss.
Initially, it will be just a random guess.
Yes.
Any random action.
Yes. So initially, the policy that the model assumes would be something random. So whatever it is predicting is a garbage output that I'm getting at the end, right? But sorry. But because this is wrapped up with the env class, right? So in the model, we are actually wrapping it up with the environment. So this is actually making sure that the bounds are limited between -2 and +2 for the action space. So even if the output prediction is garbage, it is still within the bounds of the action space. Okay, basically the spaces restrict my prediction to go outside that. Okay, now we are using continuous actions, therefore the action is a numpy array. So yeah, it's printing the action, whatever we just did. Now you need to write a code for step in the environment. So we know how the step function looks like, right? So we have the action, we have observation, we have reward. What next? Okay, I should write this env.step action. Okay, this returns me something. What should be on the left hand side?
Like I guess it would return like everything about the environment, right? The observation
Yeah.
space and everything.
Yeah. So what should be be on the left hand side? So we know how the env we know how the env step function looks like, right? We saw earlier how when we designed the env.step, what all it returns. So what does the env.step returns?
The reward and if it is done or not.
Yeah, there were something, right? And you have to return that in that particular order, right? So you remember the order? So first we had the observation, okay? Then we had the reward, then we had the done, and then we had the info. Do you think this is correct? Is that what it is?
Yes. I don't remember anything apart from that.
Okay. This is actually incorrect. Why? Because here, if you remember, it's no longer done. It's OBS, reward, terminated, truncated, and info. Okay. And since we are using the latest version, there is nothing called done. You have terminated and truncated. Okay. So over here, just be careful. Need to write terminated and truncated. Oh, expected 5 got 4. Okay, is it using something older version, I feel? Yeah, so there is a catch over here. So what this pendulum version 1 is using is the older version. So if I try to use the newer version, then it's failing. So if I write done instead, so it works for me. Okay, so like I said, there is a bit of a version mismatch that is happening, and this changes is not very old. This is a very latest change where they have started moving towards the terminated and truncated. Usually this is the case. Otherwise, what you do is you write terminated, you write truncated if you are creating a custom environment, and then your done actually should be terminated or truncated. Okay, why? Because this is a Boolean variable, right? So this can take a true or a false value. This can take a true or a false value. So when I apply an or, it's a logical or I'm applying. So my done is true whenever either of them is true. Okay, make sense?
Yeah.
Okay, but here apparently they don't have that differentiation in the pendulum v1. So we'll just go with the old version. And then if I print, this is how it looks. Okay, so the random action that I took gave me an observation. I got a reward. Done is false. Okay. And then at the end of the episode, you always reset the environment. Okay, so you do env.reset. That's it. You know how to simulate the environment. So if you want to return the first observation, you do env.reset. To predict, you have model.predict, and to simulate it, you do env.step. So this is the order that will follow. Okay. Now, the function will be used to evaluate the performance of an RL agent. Thanks to SB3 interface, it will work on any SB3 algorithms and any gym environment. Okay, now here what you have to do is, so you have trained an RL model. Now you want to actually evaluate your model. So what they are passing is, they are passing you the model, they are passing you the environment, they are passing you how many episodes you want to evaluate it, and deterministic is true or false. Okay. So what I do is, I'll create a for loop for a variable in range n eval episodes. Okay, I'm creating a for loop. And in that for loop, what will I do? I'll first return the first observation. Okay. Right. And inside that, I'll do while done, while not done. I'll have action is equal to model dot predict OBS comma deterministic is equal to deterministic. Okay. So deterministic is a variable that is being passed to us. This is a Boolean false, but if it is true, then whatever is the value that it has over there, it will get replaced over here. And then you do OBS reward done info. So I'll call this OBS underscore. Okay, so differentiate between the old observation and the new observation. And this is env dot step action. And then you check if done is true, then break. Otherwise, you say that your OBS is your OBS underscore. Okay, is this clear to you what I did over here?
Yeah.
So do you understand what I just did? I just followed the process that they had. So initially, I am creating a for loop, okay? And that for loop will run for this many number of episodes, okay? Observation, OBS gives me the initial observation at the start of the episode. I use the env.reset. Then while not done, okay? So done, if it is true, then this while loop won't be executed, okay? So while done is false, actually I don't even need this, right? I don't need this done break. I think this is more than enough. So while not done, my model.predict gives me an action. Okay. Then I do this. And in the end, in the last step, I basically make the new observation as my current observation. In fact, if I'm not using this, I can also make it even more simpler. Okay, here you go. Okay, very simple code. I think around 4 lines you can evaluate. Now, what do they want? They want us to evaluate the mean episodic reward. Okay. So here what I'll do is I'll create a column called total reward. Okay. So at the start of the episode, my total reward is 0. And here I'll say that my total reward is plus equal to reward. Sorry. Okay. So let's say I'll create something called mean episodic reward. So let's say this is a numpy array, which is empty. And at the end of episode, after I'm out of this while loop, I'll just do mean episode reward dot append. Sorry, then it shouldn't be a numpy array, right? Dot append total reward. Okay. Is that fine? What we have done? So what I've done here so far? Any doubts here?
No.
I guess we have to also do the division by length of mean episode.
Yes. Yes. Yes, that I have to do. So once I have this, so I can simply just do mean episode reward is np.mean. No, what is it? Okay, then I shouldn't call it mean episodic reward. I should call it total episodic reward. Total episode reward. I'll call this total episode reward. And then this is total episode reward divided by this makes sense now. What I did.
np.mean will also give you the same thing, right?
Yes, it will, but it's not an NP array, right? This is a list. If I directly do np.mean, it will throw me an error.
Okay.
But I can always convert it to an NP array, right? So this is also fine.
NP is very fast.
So yeah, np.mean also does the job for you, but you have to specifically make it into an NP array. Right now it's a list. Okay. Now if I run this, it should return something, right? Okay, so it's a function, right? It won't do anything. But here, if I run this, so here you are saying that the total eval episodes is 20, deterministic is false, model environment is being passed. If I run this, I should done reference before assignment. Okay, so let's say done is initially false. Okay, let's do that. Yeah, this works, right? Now if I just from tqdm import tqdm, do I have tqdm by the way? Over here. Okay, I have tqdm. So if I do this, so I can just add a decorator over here. So I just call it tqdm this now. Yeah, so now you can see there is a progress bar that comes up. Okay, if I add the tqdm, so I know exactly what is happening here. So if I want to evaluate it over, let's say 200 episodes, that also can be done easily. Okay, but yeah, this evaluation is still being done on something that has not been trained. Okay, so just be aware, we haven't actually trained a model. Whatever prediction that you are getting is on an untrained model, right? Now, stable-based NC already provides you with helper. Actual implementation is a little more advanced. So you have a helper. So you have a helper called evaluate policy. You don't need to do that. You have monitor and everything, right? So this monitor wrapper allows you to keep a track of the training reward and other infos useful for plotting. Okay. So here env.seed is for, they have set it to 42. Okay. Now what they are saying is, if you want to evaluate the policy, instead of writing all this, you already have a predefined function in SD3 that does it for you. Okay. It's exactly the same thing that we just wrote. If I do this, too many values to unpack. What? Expected to. Okay. I copy that. Sorry. If I copy this, do a is equal to this and print a dot shape. Why is this string an error?
Did you run the previous cells?
I did, yes. Oh, okay. I don't know what happened. Okay, I think Here again, we are in the terminated truncated business, right? Yeah, this is slightly confusing. And then you have done is equal to terminated.
Which environment is this?
I think it's still using this pendulum environment.
Okay, but earlier that pendulum was done right.
Yeah, I don't know. That is something confusing to me as well. Now does it?
Maybe
Yeah, now it's not working.
Maybe it's a custom environment.
No. If I go here, okay, let's run this again. This is pendulum. Do this. Go here. Go here. I go here. This is fine. This is fine. Now this. Okay, very strange. Yeah. Okay. Then I should stick with the original done, right?
By the way, are you using a gym or gymnasium?
I'm using okay, here. It's a good question. I didn't check actually. Yeah, they're using gym over here, right?
Why did they create gymnasium in the first place? I didn't understand that.
I think it's a latest update that they have made. I think they are trying to move from the old gym to something new called gymnasium.
Okay.
Yeah. So let's say I use gymnasium everywhere. Now I think if I want to make everything.
It's a very cheeky technique, import gymnasium as gym. And then
Yeah.
everybody gets confused.
Yes. So I should use gym. So because when I actually migrate my codes from gymnasium to gym, so I don't want to change a lot of things. So that's why I just import it as gym so that.
Yeah, I get it.
What happened? What's the issue now? Okay, I should run this. What? You have passed a tuple to the predict function instead of a numpy array or a dictionary. Really? Oh, okay. We need to have a dictionary that is being returned. Otherwise, it's a tuple. Okay. This. Yeah, it's slightly confusing right now. I know many people are getting confused when I'm continuously switching between gym and gymnasium. So I'm trying to make everything to be gymnasium so that we are at the current development stage, right? Okay, I'll just do a quick recap. In gymnasium, you have the init, you have the make a super call to the gym.env that is there. Super init is there. When you're calling the reset function, you need to define a seed parameter. Okay. You need to define an info. So your reset, instead of returning one thing, it returns two things. One is the observation and the other is the info. Okay. So the reset returns you two variables. Step returns you five variables. And in this particular order, you have observation, reward, terminated, truncated, and info. And then you can add additional functions. Okay. So this is the whole recap. And I'm trying to be consistent with that. So for env.reset, since it returns two variables, so I just make it return two variables, but I'm only interested in the OBS. This is not of interest to me. Okay. Now you have model.predict. You have your terminated truncated. This works. And then maybe you say your done is terminated or truncated. Yeah, now things should work. I should add this. This is fine. This now should have a terminated and a truncated info. And I uncomment this. Yeah, now I think we should be fine. Okay. This is for the custom evaluate function that we defined over here, right? Okay. And yeah, you have this. I don't know, maybe if I comment this out and I run this, does it still pendulum object has no attribute seed? Okay, let's comment this. It's not there. Okay, so now it evaluated everything and it gave me back my mean reward and the standard deviation, right? So this one can make use of to, if you don't want to write that code. So stable baselines offers you this always. Okay. Are we clear till now? Any questions? I think I should pause for a bit and interact with you. Yeah. Anything you don't understand, if I have been too fast or something like that, please.
No, apart from the gym and gymnasium one, I don't think there's any other confusion.
Okay. So yeah, we are using gymnasium. Okay. You just try to wrap your head around the gymnasium part. So you need to, not a lot of changes, it's a few changes, mainly with the done and with the reset function, and rest everything remains same. And of course, the import is not gymnasium, it's gym. So only one thing over here, some things over here, and then you will need to define the seats and options over here. Okay, it's just you need to know the main skeleton of how the gymnasium class looks like, and afterwards everything else can be customized as per your needs. Okay, so where were we? Yeah, we evaluated, we did this. Now you want to train. Okay, so train is very simple. You just do model.learn. You define total time steps to be whatever is the number of time steps. Again, I said earlier also, stable baseline tree doesn't train based on the number of episodes. It based on the number of steps. Okay, because your episode, if your episode's maximum length is 100, sometimes the episode can stop at 10 steps. Sometimes it can stop at 50 steps, depending on the termination or the truncation conditions, right? So it actually trains for the number of steps. If I run this, what it does. Okay, so this actually returns me something like this at each step. Okay, so I'm running this for 50,000 time steps. Okay, maybe if I stop this, I should have a progress bar is true to see how the progress looks. Okay, let's see. Okay, so there is a progress bar. It is when it is training, this shows up, and you have a rollout. Okay, so you know what are the things that are being printed. So these are being logged. Okay, anyway. So if you want to plot this, you have a plotting function that can plot how the episode mean length looks like with the increasing number of steps, how the episode reward mean looks like. So this is this value. Then these are some parameters for not exactly related, but these are like some low level parameters. These are the parameters very specific to the RL algorithm that you're using. So here we are making use of PPO, right? So these are some parameters that are hyperparameters that are very specific to PPO. So this also gets tracked. So you see everything is getting tracked over here. I have a long list, and everything gets logged, and you can actually use TensorBoard to plot all these values as well, right? So I think the training is done. Yeah, so we trained it for 50,000 time steps. Okay, so you see in PPO, it actually went a bit ahead of it. Yeah, any questions? Yeah.
In the 50,000, why is there an underscore in between?
It's just a way to, so you can't put a comma in this, right? So it's like a replacement for
Valid
comma.
number?
Sorry?
That's a valid like Python integer?
Yes, it's a valid Python integer. So like when you have big digit, you put a comma, right? In that, after every third digit, you put a comma. So instead of that, you put an underscore, and that's valid.
Okay, that is something new, nicely.
Yeah. You can check this also, I think. If you just go a is equal to, let's say I want to define 1 million. Okay. If I do print a, see, it works, right? But if I do a comma, then maybe it reads it as something else. Okay. So the comma has a different meaning over here. Okay.
Yeah.
Okay. So now the model has been trained for 50,000 time steps. Okay. You obviously should train it depending on how the performance looks like, how the reward curves look like. So if you see that the reward hasn't saturated yet, so let's look at the reward. Okay. So the reward is minus 1.23 to the power 10 power 3. Okay. So around minus 1230, right? And it is decreasing. It reaches minus 936, minus 818. Let's see if it's saturated. Minus 363. Okay. Minus 320. Okay, so it was still decreasing. Okay. And it hasn't saturated at a certain number. So if I, let's say, train it for longer time, let's say I train it for 100,000 time steps. Let's see how the performance should look. It should take around 1.5 minutes. Let's see.
So 100,000 time steps means like for every episode the number of time steps are added.
Yes, number of time steps are irrespective of the length of the episode. It is tracking the total episodes that has been, the total time steps that has been covered so far.
And what if at the 10,000 time step or episode hasn't ended?
So PPO behaves differently. So if you saw earlier, so here it was 50,000, but it went till 51,000. So PPO actually goes till the end of the episode. But some algorithms like DQN or soft actor critic that are not a non-policy algorithm, they actually terminate at that instance itself.
Okay.
Yeah, it's like the way an off-policy and on-policy algorithm behaves. But I don't know if you're familiar with those terminologies yet.
Yeah, I am.
Okay.
I had a doubt actually. Where did we mention
Yeah.
how long one episode can last max? Like
Oh,
how many times can
that
it last?
actually we are using the pendulum environment, right? So the pendulum environment has the max episode defined. Otherwise, if you want to create a custom environment, your done statement defines that for you, right?
Okay.
So in your custom, so let's say you can have your done statement instead of it being false. You can have a condition, right? If number of steps is equal to max number of steps, then done is true.
Okay. Yeah.
That is, I'm believing that the environment is aware of the length of the episode. Okay. Okay, this is done. Now, if you, let's see where it is. Okay, see, it's decreasing. It went till minus 187. I don't know why is it increasing. Or maybe that is a saturation point around minus 190 to 200. Okay, it's fluctuating a bit. Okay, why is it increasing? Not sure. Yeah, I'm not sure what happened here. Why it decreased and then suddenly increased. Okay, maybe we can.
Yeah, it is deterministic.
Yeah, sorry. It is deterministic. Where did we define that? So we haven't defined that, right?
So maybe that is the reason why it is doing like that.
No, but RL agents should learn to, even if it is not deterministic, it should learn to account for the variance. But yeah, I think it's just a random aberration that is happening. If you train it for long enough, let's say not 100,000, if I train it for 1 million, then maybe it works. I'm not sure, but yeah. We'll have to maybe explore that later. If I train it for 1 million, it'll take longer time to do that. So I'll just skip that for now. You guys are free to play around with it. So once this is trained, we evaluate what is the mean reward. So the mean reward is around this. That's what we also noticed, right? So this was the mean reward we were getting at the end of the episode. And this is the standard deviation, plus minus 100. Now apply the apparently the training went well. The mean reward increased a lot. 1 second. Yeah, okay. For 50,000, the training did went well. So set up a fake display, otherwise rendering will fail. So they have some code lines written to set up a display. And if I run this just to visualize how the agent looks. Render must be RGB array. Did we not define that? Not none. Where did we define that? Where is render? Okay. This was render. This is there. One over here. Where else is there? Where can I change the render? Can you guys see anything? Where we have called the render function. See record video.
I think the fake display has not been set properly then. That's why it is
The
failing.
fake display. Okay. But yeah, in the render, you can change that mode, right? So you just change the mode to RGB array. I don't know why this is not happening. Again, that is one issue, right? With actually looking at old tutorials, because this field is continuously evolving. So you realize this tutorial, which was designed in September 2022, now doesn't work because a lot has changed since then. Okay, so you guys need to stay updated with the latest development that is happening. If you miss it, then you have to go back to the previous version, or you need to learn how the new version works. Okay, let's say the display, I don't know how to make it work. I don't see the render. Where is it? Assert render mode, RGB array. Render mode must be RGB array, not self.render mode. Okay, I think something is happening at the backdrop that I don't have a control over. So ideally, if this should run fine, you should have seen the visualization, but apparently I don't think that we have this working. If I run this, yeah, there is no video, right? It's not recording anything.
I think in the pendulum B1, right?
Mhm.
It initially like just set that variable render is RGB array.
Is there a variable like that I can set? Let's look at pendulum B1.
Environment dot render, right?
Oh, but where is env.render? So if I go here, yeah, render mode is optional, right? So I just set it to RGB array, render underscore mode. Okay. Where is it now?
Yeah, there I think it should be good.
Yeah, but we are not making it the way we are doing it in a different way, right? We are doing gym.make and passing a string.
Yeah, I think that should not be an issue. You can do env dot render. You can keep that. From in the next line you can add env dot render mode equal to RGB array. Yeah, somewhere there you can add.
But render, it won't set the mode. It will actually, sorry. No, there is no method to add in render. It is always done at the init step itself.
Self dot render mode is none.
And that render mode is defined at the init. Okay.
Okay.
Yeah. So yeah, let's, unless you import the pendulum v1 and then call it in a different way, it won't work for now, I think. So I think we'll just skip this for now. So we don't have record video and so on. Then you have optional exercises, save, load the model, and that the loading was correct. Okay, so you know how to sample observations using the environment. So you have OBS is equal to env dot observation space dot sample. You know how to sample, you know how to predict. Predict is what? Action. This is model dot predict. Your OBS and your deterministic is true. Sorry. Save the model. Now, how do you save the model? You say model dot save, and you write a name for that particular model. Let's say pendulum. Okay, so this saves the model. I don't know where it's saved for me. Yeah, it's saved in this pendulum.zip over here, right? Okay, this deletes the model that you saved, and then you want to load it. Let's say I don't delete it first. I'll first load it. What is the name? Pendulum, right? Pendulum into this. Yeah, this works, right? I just save. Okay, the zip I have is pendulum.zip, and I can do what? Oh, okay. Wow. If I delete the model, then model is not defined. Okay. Okay, it should be like this. Model is ppo.load. Okay, this works like that. Okay, so your algorithm is ppo, so you do ppo.load pendulum and then predict action. You can predict actions again using model dot predict OBS. Okay, this works. Then you have action before saving, action after saving, loading. Okay, I should name it action before saving. Right? I should call it action after loading, right? Okay, let's run everything probably again. I don't know. I messed up somewhere. Okay.
Manav, I have added one line in the chat in the Q&A.
Mm-hmm.
You can add that in that gym.make, right? You can add it there. Instead of frozen lake, you can keep the pendulum v1.
I can add this. Is it?
Yeah, as a parameter to that gym.make.
Okay, let's see over here.
Yeah.
Okay. Okay, interesting. Let's say it works. Yeah, maybe 20 episodes. Trend this. This works. So I'll do this for what the original time was. It'll take me around 40 seconds to train. Let's see. Okay, I think training is done. Let's see if I can record. Okay, interesting. Okay, still doesn't work. I don't know why.
Lol.
Okay, fine. Let's leave it. Okay, so I have action before saving is something. Sorry, I should change it to action before saving. Then I delete the model. The model is saved in pendulum.zip. I load the model. I do predict, and then yeah, this is just a check to see if both are same or not. If not, then something went wrong with the loading. So here we saw that how you can save and load a model. Right? So once I saved the model, I deleted it, and then I load it into a new model, and it still worked for me, right? And what else? Train a model in one line. So this is a code to train an RL model in one line. You don't need to write model.learn separately. If you just in the init itself, you do this work. This should also work. Let's see. Yeah. And then, yeah, this is the anatomy of a gym wrapper that we discussed. Okay, so some changes over here, of course. You need to have this info. We need to return. And yeah, we need to do seed none, options none. Okay, this is with gymnasium, of course. And then here you need to have terminated, truncated. Okay, so this is just a basic anatomy. And yeah, there are some other additional exercises. So do we have time? Yeah, I think we can do this, right? It's 10:30. So what do you have to do? Okay, so this is in this exercise, the goal is to create a gym wrapper that will limit the maximum number of steps per episode, timeout. Okay. So it will also pass a timeout signal to the info deck to tell the agent that the termination was due to reaching the limits. Termination due to timeout must be handled separately. You can also take a look at this issue. I think that's what they made change, right, in the dictionary, in the gymnasium. So in earlier, it was only done. Done is true only when the goal condition is reached. Whether it's a failure or a success, they didn't care. So with termination truncation, they handle it a bit differently. So you don't actually have to. So here earlier, if you see what they do is, if signal passes a timeout signal, then in the info dict, you tell the agent that the termination was due to reaching the limits. Okay. Now you no longer need to do that because you have a separate variable to track that for you, right? So let's say in the super, what you do is count the number of steps per episode, right? How do you do that? Counter of steps per episode. So max steps is 100, self.max steps, counter of steps per episode. Let's say if I define something like self.episodes is 0 initially, okay. We set the counter and I do here self.step is equal to 0. Okay, whenever I'm calling reset, I'll say that my self.episodes is plus equal to 1 and self.steps is equal to 0. Okay. Return observation. Oh, okay. Should move. Oh. And OBS is self.observation space dot sample. But again, I didn't define the observation space. The space is low is minus np.env, high is np.env, shape, let's say, is 6. And let's say I define same for the action space, just defining something randomly. Okay. And this works, I should have a info. Return this. Yeah, I think we were doing this anyway with the terminated truncated. So here they are actually saying that in the info you pass that episode was terminated because of a timeout. So you step into the environment, increment the episode counter. So what we do is, in this case, self.steps first is incremented, and then you have OBS is self.reset. Because there is another variable that you need to return. Then while not done, you have self.step is your action. Action is an argument over here, right? So you have OBS reward terminated, truncated, info. Then you have done is equal to terminated or truncated. Okay, so again, you check if done is true. So if done is true, yeah.
Manav, since this is self.step, right? So in step you will just perform one iteration, right? You'll not do while not done, right?
Sorry.
Like since it is a step method, so for step you'll only perform like one action at a time, right? That is not an episode, right?
No. But I
So
need to repeatedly perform steps, right? While done is not true.
but this you will write in your main code, right? While not done, this you'll write in your main, right? This is just a step. So every time you're calling your step, I think when you do self.step action, then maybe it could go into a infinite loop or something.
Yeah,
Because
I realized that. Yes, I'm doing
yeah.
something else. Okay. Let's say I do self dot observation space dot sample. Then what else? My reward is, let's say, 1.0. Terminated is false. Truncated is false. Then I need to create a condition that if terminated, then you should add this info for that particular episode. So your self.episode is timeout reached. Okay, so this is just a dictionary that is being returned. So if you do this, now you are actually populating your info, right, to know which all episodes got terminated or truncated. I should first define infos as a empty dictionary first. Let's see. This works. Box object is not callable. Ah. What does that mean? Where did I call box?
Since it's a wrapper, I think you don't need to like again define like what is a step and all that. Like all you need to do is just check like if the number of steps is exceeding a certain value, just say like timeout exceeded. That's all you need to do, right?
What should I do here? Nothing.
Here I think you should call some super dot step or something, or super dot reset or something.
No, but it is not make. It's not okay. It's a wrapper classes. Okay, so I think I have to use some wrapper class separately.
Wait. Since it's a wrapper class, right? So I don't think
Yeah.
you need to do that at all. I think it will already do, because in the wrapper at the end the codes will, these lines are getting added to the original code, right? So you can definitely like ignore all the parts you don't need to do. Like
Oh,
observation space, action space, you can all ignore because like it's a wrapper, right?
yeah, I think this is where I was making some mistake, right? Yeah, let's try this. This. Yeah, okay, it works apparently. So is it returning anything to me? Has no attribute episodes. There is episodes. Pendulum object. Why is it still pendulum? What? Wait a second. Oh, okay. I don't need to add all this. What just happened? I don't know.
We have written in the reset self dot episdos, like just a typo in the reset वाला self dot reset. अब ऊपर ही
Yeah.
up yeah, in there self dot reset self dot.
Okay. Value values don't have, okay. Okay. Yeah, I think it will take a long time for timeout to be called. That's how max steps is 100. Okay, I see. So they want us to call timeout once your max, if your number of steps reaches the max steps, then you should call timeout, right? That's what they want. Yes. Self dot steps is greater than or equal to self dot max steps. Then you call a timeout. Okay. I'm not doing it correctly, but let's see. Yeah, okay. I think this will take some time. You guys should try to look at it. So I think we have some good 20 minutes left. So okay, I can do one thing. So I actually created this kind of an environment. Okay, so when I was a teaching assistant for this course in my university, so this was an assignment I made for the students. Okay, so this is an environment called the warehouse environment. So there is a person. They have a delivery box. So the person actually goes here, reaches at this place, and the person can only push the box from behind. It can't pull the box. And the goal is to to help make the box reach this target position. Okay, it's a very simple environment. It's a very deterministic environment. Nothing changes. The person always gets initialized over here. The box and the target are always over here. So the assignment I had given was your job is to create this environment in your write your own custom code to create the environment. So you need to define what your step function looks like. You need to define what your reset function looks like, and so on. So I have some code. So one student had written some code. So, but it's not perfect in any way. Okay, so this is just a code a student had written. So maybe what I can do is instead of giving you the code directly, maybe I should ask you to try this yourself on your own. So maybe I can share this image so the task at hand. You can define, okay, this is a wall, this is a empty space, and so on, and see if you can come up with a custom gym environment that actually solves this problem. So in this assignment, none of the student was able to get this working correctly, but now stable baselines 3. Okay, you know how to create a gym constructor. So I would actually want you guys to see if you can try this. So maybe when you have a next meeting of your club, you can probably discuss solutions around it. Okay, I think this is a very good example. So if you guys are able to code this into a custom gym environment, then I think you will have a good hands-on understanding of what how one can create your own gym environment, and then probably you can uh, start your journey for reinforcement learning better. So when you have your actual courses starting, so this will help you actually. So I don't know, maybe you guys take a screenshot of this, or should I share it in the chat? What should I do?
You can share it in the Q&A section. Maybe.
Okay, I'll take a screenshot. Okay, and I'll share it in the Q&A. So it's like a very simple, it's like 6x7 grid. Okay, so let's do this. And I go here. I don't know, can I attach images? Okay, I can't attach images apparently.
Or maybe like you can maybe just send it to me.
Yes, okay, I'll do that. Okay, sure. So I want you guys to actually take some time, think about it. If you have time over from your college, try to do this activity. I think this would be a very good starting point for you guys. Okay, so you know how the skeleton gymnasium a skeleton gymnasium class looks like. You know how to train. You should always go back to this example. This is something that I had shared yesterday also, right? This link. So you go to this particular link, and this is the fourth one over here. This is what I was running today. So try your hand at it. Let me know if you face any difficulties. You know, you can always reach out to me. So you guys can add me on LinkedIn, and if you get something interesting, please let me know, because for now, as far as I know, this is still an unsolved problem. Many people tried, but they weren't successful. So I want to see if you guys can make any progress on this. Okay. Sounds good, right?
Yeah.
Okay. So I think, yeah, that's mostly what I had in mind to cover. So I think this tutorial already covered all those things for you guys. So yeah, let's chat a bit. We can stop sharing the screen. So yeah, so we come to an end of this 3-day workshop. So you can ask any questions you have, or you feel anything you want to chat about. Okay, maybe I should ask you this question. So let's say when you reach your final year, or let's say you reach your third or fourth year, so you might have to do some project work, right? So can someone come up with a potential application of RL that you can use to solve a problem of your choice? I assume you guys are from different departments, different field and experiences. What do you think could be potential applications that you would like, or do you think RL could help perform better?
Actually, it's a very ironic question for me, because like my last year project is on an RL only.
Okay.
So my project was like autonomous drone navigation system, and like there were many components to that. One is like the thing is like we change the problem statement in the middle of the project, and those all stuff. But like the goal is like imagine there's a very big grid, okay, and or think of it as a very big field. You have to reach every part of the field, and you have a drone, okay, and that drone has some like area, like it has, maybe it has a camera area, like the cameras can reach a particular area, or it has some other like maybe it's using as a pesticide or something, so it has a range or something. So the drone has to reach every corner of the field, but at the same time, yeah, at the same time, like if there is any obstacles or anything, you have to avoid it.
Okay.
So
Okay.
like there is like two parts to the problem. One is like you have to consider the like total field area, and you have to consider it in the, like I considered it in the like terms of small grids of the number, like a range of the like camera. So if you see, that will be your boxes, like which places are visited and not visited. So
Understood.
one is like reach all the squares. That is one thing. And second thing is like within the squares there could be a smaller obstacles, like it could be a pole or it could be anything. So within the smaller obstacles there is like individual some pebbles or something, some grids, like that bigger grid, that camera range grid is divided into further grid, and you have to avoid the things, avoid the obstacles. So
Got it.
yeah,
So
and
what happened?
we
Not
did it
getting
as
good. Oh, okay. Oh, it was successful, right?
yeah, it was successful. It is actually still in progress. Like I've done the both the individual parts, like I've done the covering of the entire map and the obstacle avoidance. I just need to combine everything.
Okay. So are you training two different policies for these two?
No, actually, I just used Q learning because
Oh.
the grid was very small, right?
Mhm.
So if you use other policies, then it will take a lot of time. And the thing is, like for every smaller grid, you have to run it.
Okay. So why don't you try stable baselines then? Use PPO, try stable baselines and see you will get faster convergence, better training because Q learning is not deep learning, right? It's
Yeah, yeah,
simple or maybe try around that.
yeah, yeah. Actually, I should.
Yeah.
I'll do that.
Yeah. Anyone else has any idea apart from this where one can think of application, anything like something that comes to your mind? One is in robotics. Okay, I work in the field of robotics, so my research focus is mainly in the area of multiple drone and their cooperation in monitoring a certain area continuously, right? So robotics is one application, autonomous driving is another application. People actually use this in financial markets, in healthcare. If you have any specific problem, okay, think of it, see how you can convert it into an RL problem. Okay, so you need to define what the state is, what the action is, and so on, and then maybe you can try implementing it. So now I am assuming you guys have a good hands-on exposure to working or getting started with RL. Again, anyhow, if you have any questions later on, you feel free to reach out to me. You guys have my contact, email, LinkedIn, everything, right? So yeah, I think that's it from my end. Anything else?
Manav, out of curiosity, I want to like ask you one thing. Like, imagine you have just a problem statement. Okay, just a problem statement. So this is the problem statement of visiting every square. So we did it in a way, and it was very limiting. So just want to share that with you. So imagine you have a like 5x5 grid. Okay,
Okay.
and you have to visit every grid. Okay,
Mhm.
and there is a like your path is saved, means like the path, if you go up, right, left, down, these are the actions, up, right, left, down, these actions, and you have to navigate or something, but leave that, just you have to ensure ki like where you are, which path you have taken. So to understand which path you have taken, isn't it like the state space will become very large, because you need to keep a like boolean value for every state where it is, like for example for 5x5, it will be like, you can imagine like it is a binary number like of the length of 25, and then it is which represents one, every binary number represents every square in that grid, and it will be 0 and 1. And so the problem is like, when once you think of it in that way, now the your state space becomes, see, think of it, your state space become very very large.
2 power 25 basically,
Yeah,
right?
yeah, 2 power 25 is very bad.
Okay. So yeah, that's why we don't typically rely on Q learning, right? Because when you move to deep learning, you are naturally dealing with very large state spaces, like millions, billions of size of state spaces. So Q learning in that way is very limiting. Also, is it like you have to visit each square exactly once? Is that
Not
right?
necessarily, but it is like if you are like visiting it twice, then it is penalized. So
It's penalized. Okay. Okay. Interesting. So maybe you change the way you define your state, right? So instead of defining it whether it is visited or unvisited, you can always define it like this. So let's say I have a 24 length vector, which is initially set to 0. Okay, every value is set to 0. So, but it's the same thing. Yeah, I don't think you can reduce it any further. So,
And the funny thing is, like, we ran it on Collab, and that Collab, we got it ready for a 4x4 grid. Now imagine when you have a drone and you can only use a 4x4. In real life, that is nothing at all. In real life, the drone is very much more precise. 4x4 grid is nothing. And when we tried on 5x5, the Collab got it got overloaded.
Yeah, that's why people moved on to deep RL, right? Because classical RL, with all its beauty and all its theorem and proofs, even though it guarantees performance, but it's very limiting, because in Q-learning also you have to take an average over all the different states that you have visited, and for the average to be precise, you have to visit it multiple number of times, right? So that is natural with Q-learning or any value iteration, policy iteration that you want to use.
And that the funny thing is, like, the way we define the reward function is like, once you got a string of or a binary number of all ones, like if you get 2 raised to 25, then you get a very big reward. Otherwise, you don't get anything at all.
Oh, that's not a good reward then.
Yeah.
You should have some intermediate secondary rewards that leads you to that big reward.
We defined it in a way like, if you take steps, okay, if you take any amount of steps, it will constantly decrease. It will be like minus 0.01, something like that. And once you reach the goal, it is like 100.
Okay. Yeah, this is again a part and parcel of designing your reward. So you need to sit down, think how the reward should be, like whether you want to penalize it more. So interestingly, one behavior that I notice is, if I make my penalization to be very high, then the agent is very fearful of exploring.
Yeah.
So there is always a fine balance or trade-off that people do. So yeah, like we said, like designing a reward is very difficult. So right now there is a very hot topic running on. It's called RL with human feedback. Are you aware of this term?
Yeah.
RL. So what they are doing is, they are saying that you don't need to handcraft a reward. So it's like this: you put a human in the loop. When you're training a reinforcement learning agent, you don't define a reward function. Instead, you add a human. So whenever you have a model, you roll out two trajectories. Okay, the model will give you two trajectories. You give these two trajectories to a human. You give pairwise trajectories to a human. The human will decide whether the human prefers trajectory 1 or trajectory 2. And based on that, there is another neural network that learns from the human preferences on what the reward should be like.
Yeah, that's interesting.
But yeah, this is still in very early stages, and I think this is currently the hot topic in RL community. This is something that I'm also exploring right now. So maybe try with deep learning. That I think should be the first step for you.
We actually tried it, but then got into the errors. Both are errors. So we got stuck in that.
Errors in what? In the environment.
The environment was okay. The environment was actually the easiest thing was the environment. The code from scratch was difficult for the algorithms.
Yeah, then try this table baseline, so you don't have to code anything. Maybe you
Yeah,
can
actually,
directly.
I should do it. I will do it actually.
All right, then. Anything else? No, right? Okay, then. I think it's a good time to stop.
So
Thanks a
guys,
lot.
with this we conclude the last day of our 3-day reinforcement learning workshop. We thank Manav for sharing his wonderful insight in the field and for guiding everyone in the field of reinforcement learning. We hope this session motivated you and piqued your interest in the field of reinforcement learning and machine learning in general. Thank you everyone for attending. Thank you, Manav.
Okay, thanks a lot. See you guys. Bye.
Thank you.
Bye.
Thank you.